All right, welcome back. So now we're going to do another example that I think is interesting. And again, it takes a little bit of thought, kind of thinking about things a little differently, or just kind of pausing. Sometimes when something looks kind of different, just got to pause and think to yourself, okay, what are they giving me here? And then just work through it, okay? So what do you notice here? It says write cosine of arc tangent 1 plus arc cosine x as an algebraic expression. So the first thing that might look weird is this, okay? So how do we tackle what's going on here? So we understand, right? Problem solving 101, understand the problem. So let's understand what they're giving us here, right? So we're taking the cosine of an angle, right? So these have to be angles, and of course they're angles because arc tangent, right, is an angle, right? So if I'm taking the inverse of a number, I'm looking for an angle. So it makes sense that this is an angle and this is an angle. So I'm adding two angles. So basically, in the end result, I'm looking for the cosine of an angle, right? So why don't I just give these variable names, right? So let's call that u, call that v. So now we know it's in the form of cosine u plus v. So let's write out the expression, the identity for that, okay? And then see where it goes. So cosine, I'm going to write these in inverse form. Cosine tangent inverse of 1 plus cosine inverse of x is equal to cosine of tangent inverse of 1 times cosine of inverse cosine of x minus, right, sine of tangent inverse of 1 times sine of cosine inverse of x. Okay, so that's what I've written down. Oops, hold on. Okay, now, so let's think through this. What angle? So in this case here, we're looking for an angle, right? So ask yourselves, the tangent of what angle equals 1? The tangent of what angle equals 1? Okay, so let's write that over here, right? So if I look at this, tangent of u, right? Because this cosine, this arc tangent 1, that's u, right? So u equals the tangent the tangent of u equals 1, right? So again, what angle, if I take the tangent of that angle, equals 1? And that's going to be pi over 4, right? So I could add a step here and just say, okay, well, cosine, then I must be taking cosine of pi over 4. So now let's do the next one. This is inverse cosine of x, right? So we're saying what? Cosine, oh actually, you know what? We don't even need to do that. Because these are inverse functions, right? So cosine of cosine inverse, they cancel each other out in a sense. And so we're going to get x, right? All right, there you go. That was easy. Now, sine of tangent, let's, again, what's this one? This is still, it's the same thing. It's going to be sine, minus, gotta have minus sign, sine of pi over 4. Okay? Times sine of cosine inverse of x. So now we're going to use the same thing over here. So that means what? V equals, right? V equals cosine inverse of x. So that means cosine V equals x. And what does that give us? So inverse cosine of x, cosine V equals x. Okay, so this one we're going to have to use our triangle. So in this case here, cosine, let's say this is V, right? So that's going to be what? X over 1. And so the missing side is going to be what? It's going to be, let's do this, x squared plus y squared equals 1. And so then what do I want to do? Yeah, let's do that. Let's see where this goes. I don't want to use two variables. I don't think I want to use two variables, but let's see where this goes. So we're going to solve for this. So y equals the square root of 1 minus x squared. Okay, so that missing side is 1 minus x squared. Okay, so let's see. So now that we've got all three sides, right? Let's plug this in. So this is going to be the missing side. So it's going to be sine sine of okay, so sine of this, so sine of V, right, is going to be, okay, so yeah, let's just plug this in because we can use this triangle. So sine of V is just going to be what? This over this, which is just the square root of 1 minus x squared. Okay. Now the rest we could just do because cosine of pi over 4 is the square root of 2 over 2 times x minus, again, the sine of that is still the same thing, square root of 2 over 2 times this expression, okay? And so now what we could do is we can combine these and we get what? We get square root of 2 times x minus the square root of 2 times the square root of 1 minus x squared all over 2. And in this case here, it might be better to leave this, instead of rationalizing it first, just leave it as 1 over the square root of 2. Let's go back here, because I think it might look better in the end if we just leave this as 1 over the square root of 2. I know normally we rationalize the denominator, but in this case here, what we end up with is x minus the square root of 1 minus x squared all over the square root of 2. And in that case, that actually looks better. And that's it. Have a great day.